A ship is sailing due north. At a certain point, the bearing of the lighthouse 12.5 kilometers away is north 38.8 degrees east. Later on, the captain notices that the bearing of the lighthouse has become south 44.2 degrees east. How far did the ship travel between the two observations of the lighthouse? So the first thing we need to observe here is, take a look at this here. We have north 38.8 degrees east and south 44.2 degrees east. When we look at this, we're like, whoa, I have no idea what's going on. But I want you to take a look at this. So I pulled this from the book. Now this says down here, method 1, when a single angle is given, such as 220 degrees, this bearing is measured in a clockwise direction from north. So in a sense, when I see this 220 degrees, I'm starting here. So then I take that around 220 degrees, which puts me over here. And this is actually the direction we're traveling. Okay, that's when I see a single degree all by itself. Okay, now the second method says this, which is here. Start with a north-south line and use an acute angle to show the direction either east or west from this line. So that simply means, south means I'm starting in this southward direction here. Okay, and then it says 40 degrees west. And then that's where I'm going to draw my other one at. And this is actually going to be the direction we're traveling in right here. This is just my starting point, just like it was for the first one. So just in case you're not sure, and I didn't think about bringing this up, but do you guys understand that this is north, east, south, and west? Honestly, that's the first thing to understand with any of these. And if you don't, make a note of that. So north is upward, east is to the right, south is downward, and west is to the left. So if you need to write that down when you're dealing with these directions. And then south makes more sense. I'm going downward, right? And then west is going to the left, so that's why I'm going 40 degrees that way. Okay, so there it is. Okay, so now let's get to our problem. Because the biggest idea for any of these, I should say not any of them, but most of these problems is the fact of drawing a triangle. So most of the problems in our trig class is going to just be simply drawing a triangle. And it's not always that simple, but that's the big idea. So now think about this. I have this lighthouse here. Okay, I'm going to label it as L, and there's my point for the lighthouse. All right, so then I got this ship sailing, and I'm starting, let's say, down here. And it's saying that this distance here is 12.5, oops. I'll make it a little bit bigger. 12.5 kilometers. And it's saying I'm traveling due north, and it's saying this angle is 38. I'm just going to draw it down here. 38.8 degrees, because I'm traveling north, because that would be my north, would be in this direction. And then 38.8 degrees east would bring it over here. And that's what that angle is there. Because east is to the right, right? North, east, south, west. Okay. All right, so now I'm traveling forward. So that's going to be 38.8 degrees. And as I'm traveling, and I check later on, then I see, hang on, now I'm here. And now it's telling me that my distance now, not my distance, but my degree of my angle now is going to be, it says south, so it's in a downward direction, so that would be down this way, south, 44.2. So this here would be 44.2 degrees east, so this direction. Okay, so that's how that works. So this actually gives me a really nice triangle, and I'm just going to redraw it to the right so you can actually see it. Now, if I'm thinking of the law of sines here, because I will need that, because essentially I need to know this distance here, because that's what it says. How far did the ship travel? And that's what we're looking for. So we need to find D here, this distance. Now that means I would have to know this angle if I'm going to use, so that I can use the law of sines. So that's what we're going to look for now. How do I find that angle? So again, I just go back to the idea that we had previously. I knew that all three angles add up to 180 degrees. So essentially, I'm just going to add the two together, subtract it from 180. And we find out that that angle equals 96.7 degrees. So that's my angle L. So that's right here. So now what we're going to do with this is we're just simply going to use the law of sines here. So here's the setup. So here's our setup. And I picked the sine of 44.2 because I needed to know an angle and a side opposite the angle. So that's why I picked that one. That's going to be a necessary step for any of these problems we do using the law of sines. I have to have a side and then an angle opposite the side. So if I don't have that for my triangle, I can't use the law of sines. So something to think about. Okay, so anyways, so now we're just going to cross multiply. Now I'm just going to work through using my calculator. And just keep in mind when I do the sine of 44.2 degrees, I will have to have my calculator in degree mode. So just things to keep in mind. And this is what I end up with. Now I showed all the math for this except for the final step. Once I divide all that out, I get that D equals 17.8 kilometers. And that's going to be our answer for this one once I do all that math here on the right, which is right here. That's what I end up with. So, and again, I rounded to the first decimal place because when I look at the problem, I see 12.5. So that tells me I'm going to round to the 10th spot. So just little indicators like that look for in the problem. And there's your answer. So you get the right answers on the homework and for the tests.